So our objective today is still solving linear equations and verifying solutions. So the first thing we have to think about are what are the steps that we could follow to solve an equation with variables on both sides, and what type of solution should we anticipate having. So we've been working on solving our linear equations with one variable, and we said, can we eliminate any fractions? That would help us with our solving techniques. In order to do that, we can multiply both sides of the equation by the lowest common multiple, or the common denominator, and that will undo the fractions. We talked about the distributive property of multiplication over addition. Can we combine like terms on each side of the equal sign? Can we eliminate the smaller variable? Can we undo the order of operations? So remember, order of operations talked about the grouping symbols. First, looking for exponents or powers, then talking about multiplication and division left to right, addition, subtraction from left to right. For undoing it, we're going to do it in the reverse order. So we would look to reverse the subtraction additions, multiplication divisions, then do powers, and within those grouping symbols. Okay, remember when we want to check the solution, we do the order of operations in their correct order. We're talking about the types of solutions. Remember, we can have three things happen. We could have one solution when we verify that it makes the equation balanced on both sides. We could have no solution, which means the equation, when we check, gives us a false statement like 5 equals 10 or A equals B. We could also have infinitely many solutions where it's a true statement, 10 equals 10, A equals A, and so on. So let's try some solving and refresh our memory as to what types of solutions may occur. So here we have 7 minus 6x minus 2x equals 4x minus 17. So again, kind of following our process, we don't have any fractions that we need to eliminate. So again, do we have any multiplication over addition to take care of? Any distributions? No. Are there like terms we can combine? Yes, on this left-hand side of the equation, we see like terms of negative 6x and negative 2x. We can combine those. So this would be 7 minus 8x equals 4x minus 17. So at this point, we've got things simplified on the left side of the equation, things are simplified on the right side of the equation. So now we want to eliminate the smaller variable. Well, my smaller variable is negative 8x. To undo that, we need to have a positive, so we're going to add 8x to each side of the equation. That would leave us with 7 equals 12x minus 17. Then we have this negative 17, right? How do you undo subtraction? We add it, so we're going to add 17 to each side of the equation, which would mean that we have 24 equals 12x. So now we have to undo the multiplication of 12, so we're going to divide both sides by 12, which means x gives us 2. And again, we want to check and make sure, is this the correct solution to our equation? If not, maybe we can go back and find what step we did an error, or is it telling us something else about the equation? So let's go back to check it, and let's substitute it into the original. Here's the original equation. Again, every place there's an x, we're going to substitute it in with a 2, and that's 3 locations where it occurs. So we're going to think about, well, what are we working with here? A negative 6 times 2, that would be a negative 12. A negative 2 times 2, that's a negative 4. A 4 times 2, that would be an 8. And then I just want to simplify, well, what value would I have here on the left-hand side, and what value do I have on the right-hand side? Well, 7 minus 12, that would be a negative 5, minus 4, that's a negative 9, 8 minus 17, that's also a negative 9. That's balanced, therefore 2 is the correct value of x for our equation. Here's our second example. We have 5x minus 6 equals 5 times the quantity of x minus 1. So again, thinking about our steps from before, are there any fractions to eliminate? No. Do we have any multiplication over addition or subtraction? Yes, we do right here. So we're going to have to distribute this and see what we're working with. Well, 5 times x is 5x, and 5 times negative 1 is negative 5. Again, is there any simplifying you can do on each side of your equal sign? This side's already simplified, this side's already simplified. Then we want to eliminate the smaller variable. Well, my small variable would be 5x. It's positive. To undo that, we need a negative, so we're going to subtract it. and that gives us negative 6 equals negative 5. Well, we know that negative 6 cannot equal negative 5. Since it's a false statement, that means there is no solution to our equation. And there's nothing to check because we don't have a value for x that would make it true, so we're just going to stop and say no solution. So let's try a third example. Here we have 4 times the quantity 3x plus 2 equals 1/2 times the quantity 24x plus 16. So again, thinking about our reminders, do we have any fractions that we can eliminate? Yes, we do have a fraction here. It's being multiplied by 1/2. Remember, a fraction is the same thing as division, right? So it's like you're taking this right-hand side of the equation and dividing it by 2. So to undo that, you can multiply by 2. And we're going to multiply each side of the equation by 2 to make that happen. So 2 times 4, that would be 8 times the quantity of 3x plus 2. And 2 times 1/2, well, that would be 2 over 2, which is 1. So 1 times our quantity of 24x plus 16. So again, do we have any distribution? Yes, we do. We can take 8 times 3x and 8 times 2. So it would be 24x plus 16. 1 times 24x, it's 24x, and 1 times 16, that's 16. And check, is there any simplifying that needs to happen on each side of the equal sign? Left-hand side is good, right-hand side is good. So what's your smallest variable you need to eliminate? 24x. Since it's a positive, to undo that, you need a negative, so we're going to subtract 24x from each side of the equation. So 16 equals 16. That's a true statement. Remember, if it's true, then that means you have infinitely many solutions. Again, there's nothing to check here because we don't have a value for x to substitute back in, but since we do have a valid statement here, we know infinitely many solutions. So any value for x that I substitute in to the left side of the equation, as long as it's the same value, and to the right side, it would be perfectly balanced. So let's take a look at this one. We've got 8 times the quantity b plus 1 equals 3 times the quantity 2b minus 8 minus 20. So again, no fractions to eliminate, but do we have some multiplication over addition and subtraction? We do. So we're going to distribute 8 to b plus 1 and 3 to 2b minus 8. In doing so, we would have 8b plus 8 equals 6b minus 24 minus 20. Then check to see, do we have anything to simplify on the left-hand side of our equal sign? No, we don't. Do we have anything to simplify on the right-hand side of our equal sign? Yes, we do. Negative 24, negative 20, that would be negative 44. At this point, since each side of the equal sign is simplified, what's your smallest variable? Well, our smallest variable is 6b. To undo that, we would subtract 6b from each side of the equation. So we'd have 2b plus 8 equals negative 44. We have to undo this addition here, so we would subtract 8 from each side of our equation. So that means we'd have 2b equaling a negative 52. Then we'd have to undo the multiplication by division, so we're going to divide each side by 2. And remember, a positive divided by a positive is a positive. A negative divided by positive is a negative. So we have b equals a negative 26. Again, because we have a value for the variable, we need to check it. So we're going to take negative 26 and substitute it into the original equation every time I see a b. So that means here and here. And we would evaluate it according to our order of operations to make sure that it's balanced on each side of the equation. So we're going to substitute a negative 26 in to the left and the right. So again, grouping symbols, right? Negative 26 and 1, that would be a negative 25. So we have 8 times negative 25 here on the left. On the right, we'd have to multiply these together. So that'd be a negative 52. And then we have it with a negative 8, so that would be a negative 60. and we'd have to multiply 3 times that. So again, also 8 times this, we've got our negative 200, 3 times our negative 60, which would be our negative 180. And we know a negative 180 and a negative 20 is equal to negative 200, so it's balanced. We have the correct value for B for our equation, negative 26. Now we know solving equations given to us are great, but equations aren't always given to us. We often have times we're given scenarios and we need to model it with an equation or equations and use that to solve our problems. So let's try a few of these. It says Shane is comparing 2 different cell phone plans. One plan charges him $200 for a phone, but the cell phone bill is $30 each month. The other plan gives him a free phone, but the cell phone bill is $85 each month. How many months would it take for the cost of each cell phone plan to be the same? So the question is, what do we know about the problem? And that's where I would start. We know that we're comparing 2 cell phone plans. So if we're comparing the plans, that means we're comparing the total costs for the plan. So I can think, hey, I've got a variable here. Let's say T represents the total cost for the plan. And we know that we're being charged for the plan monthly. And we've got to figure out how many months we are looking at these plans. So it's another variable, the number of months. So let's kind of start off with T being the total for the plan, and M is the number of months that we're on the plan. So I've kind of been following our process, right? What did we know? What do we want to know? Defining variables. So we're going to catch up to what we have so far. Defining variables. Now, we know there are 2 plans, right? Say plan 1 and plan 2. Plan 1 charges them $200 for a phone and $30 each month. So think. Charges, total cost, right? T equals $200, start off the bat for the phone. So 200, and then adding on to it $30 each month. So plan 1, T equals 200 plus 30M. We got an equation. Now plan 2 has another total cost, T. It's a free phone. That's great. We're not paying anything except for the monthly fee, $85 a month. T equals 0 plus 85M. Or I could just say 85M. So kind of recap. There's our equation for plan 2. Here's our equation for plan 1. I want to figure out how many months would it take for the cost of the plans to be the same. Remember, total cost, that's the same variable, right? Well, if T equals this and T equals that, I could substitute this in for T. Then I only have one variable and one equation to solve for. The variable is M. So let's think about this. How can we solve for M? Well, what's our lowest variable? 30. How do we undo that? Subtract. So we'll subtract 30 from each side. So now we have 200 equals 55M. How would we get M alone? Divide by 55. So 200 divided by 55, that's not going to be a whole number, but we could divide out a 5 from each, so that would be 40 over 11. So our exact number for M would be 40 elevenths. Now, what does M stand for? The number of months. Would you tell someone it takes 40 elevenths months for the plans to be the same? No. So we have to think about, well, 11 goes into 40 how many times? A little bit more than 3. So if we wanted to figure out how many months, we could say, well, a little bit more than 3, but less than 4, because 11 times 4 is 44 months, and it's not quite there. You could get a calculator at this point and take 40 and divide it by 11, and you would see it's 3.63636363 to the end of your screen. So we have a repeating decimals. Remember how you do that? You take the digits that repeat and you write them, and since it was 6363, we put the bar over the 6 and the 3 to show that this is the repeating value. So we could say it takes about 3.63 months for it to be the same. We could say approximately 4 months if they're just asking for an integer number of months, but we could calculate if it's 0.63 repeated months, how many days would be the exact same if we wanted to get very specific. But this would be a perfectly fine answer for the problem. So again, what helped us answer this question? We were asking ourselves these things. What do I know? What do I want to know? Can we define any variables? Will that help us write some equations? This is kind of the guideline we should use when we have scenarios or word problems like this given to us. Let's take a look at another scenario. Bill and Kate are both reading a 500-page novel. So far, Bill has read 70 pages and Kate has read 50 pages. But from this point forward, Bill plans to read 25 pages per day, while Kate plans to read 29 pages per day. After how many days will they have read the same number of pages? Let's think about our guidelines. What do we know? Well, we know Bill and Kate are reading books. And so far, Bill has read 70 pages, so we can underline that. Here's Bill. So Bill has read 70 pages. And what else is Bill doing? He's reading 25 pages per day. Okay. Now, Kate is also reading the book. Kate has read 50 pages, and she plans to read 29 pages per day. Okay? What do we want to know? After how many days will they have read the same number of pages? So I'm going to kind of circle this here. That's what we want to know. How many days? Can we define any variables? Well, let's see. What are they talking about again? Reading pages, right? So the number of pages, we could say that's P. And what else? The number of days. We could call that D, right? So it looks like we have two variables that we're working with. Could we write some equations? I think we can. So the variables, D is the number of days, P is the number of pages. Equations. We should have an equation for Bill and an equation for Kate. And that's dealing with the number of pages read. So they'd both have P equals. For Bill, the number of pages read, P equals 70 plus 25 pages per day, 25D. Kate, for her equation, P equals 50 plus 29D, right? 29 pages per day. So the question is, after how many days will they have read the same number of pages, right? The number of pages should be the same, so the P's would be equivalent to each other. Well, if P equals this and P equals that, I could take what P is equal to here and substitute in for what P is equal to there, right? So here we have an equation. 70 plus 25D equals 50 plus 29D. All right, so let's solve for D. You have no fractions to eliminate, no distribution, so what's your lowest variable? 25D. So undo that addition here, we're going to subtract it from each side of the equation. Now we have an addition of 50. To undo that, subtract from each side. Here we have a multiplication to undo, so we'll divide that from each side. So that means that D equals 5. So it will take 5 days for Bill and Kate to have read the same number of pages. And to check, you could take the 5 and substitute in the equation for Bill, and take the 5 and substitute in the equation for Kate, and they should be the exact same, and you'll know how many pages they'll have read up to that point as well. So to recap, we worked on solving equations today with variables on both sides of the equal sign. And we also started writing equations based on some scenarios given to us. Now it'll be your turn to practice.